So hello viewers, hello students. I've come up with one more request problem. This is problem from the topic of rotational mechanics from the book Pathfinder for G Advanced and Olympiads. It is problem number 17 from the section Check Your Understanding. Now, see, let us get into the problem. Three identical light rods are rigidly connected to a T-junction. At the free ends of each rod, identical particle-like balls of mass m equal to root 5 kg are affixed and the junction is pivoted so that the frame can rotate without friction in a vertical plane containing the frame. Now the frame is tilted through an angle theta equal to 37 degree and released. Find the magnitude of the force exerted by the middle rod on the ball connected to it and the angle made by this force vector with the middle rod immediately after the frame is released. So the middle rod, by middle rod, it's meant that this rod. So that's the middle rod, and you have to find the force exerted by the middle rod on this. So let the force be F. Let F be the force exerted by the middle rod on the ball. Now that's the pivot. This one is the pivot about which it rotates. I mean the whole assembly rotates. Now you can note one thing from this problem, that it is just released. So as it is just released, due to that just release condition, that means if you look at the acceleration of the ball, see about the pivot, the ball, I mean all the balls are in circular motion. The pivot is the center of the circle about which, and presently we are concerned with the ball, this lower ball. Say name the balls A, B and C. I am concerned with ball B. Now as it is just released, that means the velocity of the ball is 0. That means the ball will only have a tangential acceleration. That means this is A, the acceleration of the ball, and this A makes an angle 90 degree with the middle rod. Okay, so here I have drawn the forces on the rod. So look at the forces mg, mg and mg, and presently I am concerned with the ball B. That's the ball B. So now I will calculate torque about the pivot. Moment of inertia of the whole assembly about the pivot is equal to I, and obviously you see I is equal to 3ml square. There it is, I is equal to 3ml square. So torque about the pivot is equal to I times alpha. Alpha is the angular acceleration of the whole assembly about the pivot. So torque about the pivot, is equal to mg L sine theta. See, only this torque will count, right? Only the torque due to this, the force on ball B will count, and this perpendicular distance from the pivot is equal to L sine theta. The torque on A and B, they will cancel each other, so that won't count. So you see here mg L sine theta equal to 3ml square times alpha. So here is the value of alpha. So acceleration A, as I have drawn before, acceleration of the ball B, which is A, perpendicular to the rod, middle rod, this A is equal to L times alpha, because you know pivot is the center of the circle and radius of the circular path of B about the pivot is equal to the length L. So A is equal to L alpha, that means G sine theta by 3. Now I've drawn the free body diagram of the ball. Yeah, that's the ball B. This is the ball B, free body diagram of the ball B. Now what are the forces? The forces are, so mg is a force, and that capital F, that means the force exerted by this rod. Just a minute. Yeah, that's equal to F. We have to find the value of F. So let's get back to the free body diagram. So mg and f, the resultant of mg and f is equal to ma, mass times acceleration. So ma is equal to mg by 3 because a is equal to L alpha. So that is g sine theta by 3. So there should be a sine theta. So mg sine of theta by 3. Okay. Just I missed out that sine theta here. Yeah. So now we can apply the cosine rule. See, look at this triangle, right? The sides of the triangle mg, f, and this mg sine theta by 3. That, and this angle is 53 degrees. See, you can see from the figure that that's so angle made by a, I mean the acceleration a with the horizontal direction is also theta. So that means, let's get back to the triangle. This angle 53 degree, so theta 53 degree, theta is 37. So now you can apply cosine rule. Let me write it now. I missed out that sine theta before. Yeah. So mg, root over of mg square plus mg by 3 sine theta square minus 2 mg times mg sine theta by 3 times cos 53, and this I have calculated. If you want, you can calculate it. Obviously this will come up as 20 Newton. Okay, now about the angle made with the rod. So obviously you can apply sine rule. You can apply sine rule there. In the given triangle, you can find out, say, this angle alpha made by force with this vertical is equal to alpha. So you can obviously calculate by sine rule that sine alpha divided by mg sine theta by 3 is equal to you know that 53 degrees, sine 53 divided by the side opposite to that, that is f. Now obviously by now you know that f is equal to 20 Newton. So that's all.